Hey guys, this is Aditya and welcome to HackSkill's Data Science Fundamental Workshop. I'll be guiding you through Module 1, right, which is about NumPy. If you have watched Module 0 with Devansh, it's great. Like, you have set up your collab, done with your Python refresher, and you know what the 4 major big imports are. Right, so today, as you can see the first slide, we have NumPy, which is the engine behind data science. Let me tell you one thing about NumPy honestly. NumPy is the reason why Python became the language of data science, Like, before NumPy, scientists were doing serious numerical work in Fortran and MATLAB. Like, NumPy brought the power into Python and literally changed everything. You won't believe me. Like, NumPy powers pandas, matplotlib, scikit-learn, TensorFlow, PyTorch, and almost every ML framework you'll ever touch. Now it's just not any other Python library like others, but NumPy plays a really crucial role, and this is the foundation of data science. Now, not talking about the introduction much, let's go to the main content, which is the video. Right, so this module 1 is separated into 2 videos, which are video A and video B. Now in video A, we will be covering arrays, attributes and slicing basically. And in video B, we will be covering operations, broadcasting and random things like vectorization and others. Like, we will be covering a mini project too in video B, but for video A, let's start. So before we start, let me introduce myself. I am Aditya Srivastava, the founder of HackSkill, which is a platform making industry-level tech education free and accessible across India. Right, so I am Oracle Certified Cloud Associate 2, and I am certified in cloud infrastructure, architecture, and deployments. Right, so apart from all this, I built HackSkill because I experienced firsthand the gap between what colleges teach and what industry actually needs. So this workshop is just my attempt to close the gap. Right, and one more thing, like, if you haven't registered for the workshop yet, you can register the workshop. The link of the workshop is in the description of the video, or if you can't find in the description, just check out the pinned comment. Right, you can get a certificate, though the content is completely free on YouTube, but if you want certification, you can just simply enroll in the workshop, where you can find the summary, collab notes and literally everything regarding this. Okay, so now let's proceed with the first slide. Like, for why NumPy is needed. Like, here you can see we have two code block. The first one is Python list, which is comparatively slower than NumPy array. You know why? Like, the Python list, the time taken is 0.12 seconds, which is almost 120 milliseconds, while the NumPy array just took 0.001 seconds, which is 1 milliseconds. Here the difference is of 120 times faster than the list. As you can see that NumPy array is literally 120 times faster than the list. You know the reason why it is so? There are 3 major reasons in this. Like, the first reason, it is because the lists are flexible. They can store strings, integers, floating values, and even other lists. But with this flexibility, there comes a performance drop, which results in this delay, or you can say the increased time complexity. Right, while NumPy array is one type, like all float 64 or all int 32. There is no type checking per operation. It's the pure raw speed. Right. The second major point is contiguous memory. Python list implement are scattered across memory as separate objects. Right, and while NumPy stores all elements side by side in a single memory block. It's just like an array in C, as it does. Here the CPU can also process it in one sweep, which results in faster solutions, right? So now the third and the last point is like C under the hood, where when you call an array, NumPy doesn't run a Python loop. It just basically calls a pre-compiled C function that does the whole thing at the hardware level, where Python interpreter overhead whatsoever. It's not required in that case, right? So this is what lets deep learning frameworks train on billions of parameters. It's all arrays, all NumPy style operations, like all vectorized. Right, so let's build some arrays with the next slide, which we have 6 ways to create a NumPy array. So apart from showing you just the visuals, let's go to the collab and just do some coding there. Right, so first So the first things first, we need to import, obviously we need to import NumPy as NP, as you all know. Now after importing, now we can perform the operations, right? So the first thing which we have here is from a Python list, we can create a NumPy array, right? So just let's do this. Array is equal to np.a1 is equal to np.array, and here we're gonna pass the parameters, right? So we're gonna pass 1, 2, 3, 4, and when we are going to print this, print a1, we'll get the list as it is, like it's 1, 2, 3, 4 itself. Yeah, as you can see this. Now the second type is we have zeros, ones, or fulls, right? This is simple one, like it consists of basically arrays which are filled with zeros, ones, or a custom integer, right? So let's start with the zeros one. Like if I create another variable a2 and store it like np.zeros and pass a parameter like 3, 3. So it will create a matrix of 3, 3 filled with complete zeros, right? So let me show you, like if I print a2 here, yeah, so it is so, like it created a matrix of 3 by 3 dimension filled with complete zeros. And if I do the same with a3, but I replace here np.zeros with np.ones, the same will occur, but here in the a2 part, this will just simply print the entire matrix filled with 1, right? So just let me show you, like if I type np.ones and I do pass 3, 3 and print a3 now, a3, so this will print a 3 by 3 matrix filled with 1. And the similar goes for full also. Like if I do a4 is equal to np.full and pass the parameters, like if I want to create 3, let's do this 3 by 4 matrix, right? So if I create this and I want the matrix to fill with the integer 5, right? So if I do this and I print the matrix like a4, this is going to print a 3 by 4 matrix filled with the number 5. So this is how this zeros, ones, and full work. Now we have the range based, right? It completely depends on the range we specify and the steps basically we provide, right? So the first we have is np.arrange. If we create an array of, if we create another NumPy array where a5 is equal to np.arrange and we pass the parameter 0, 20 and step 2, right? And we just simply print a5, we get all the integers from 0 to 20 at step 2. As you can see this, like we have 0, then after 2 we have 2, then again after 2 steps we have 4, then 6, then 8, then 10, then 12, and so on. Right? So this is how np.arrange works. Similarly, we have np.linspace, which we can represent as np.linspace. And if we do so, and do 0 to 1 and pass the parameter as 5 and print a6, and then we will get all the values from 0 to 1 at an interval of 0.05. Right, as you can see we have 0 and then basically we got 5 separate divisions in this case. It's like that. So from 0 to 1 we have 5 divisions like 0, 0.25, 0.5, 0.75 and 1. So this is how it completely works. And then we have the fourth category or the fourth method of this creating a NumPy array. Right, so it's using I function. So those who don't know about identity is somewhat like creating a matrix whose diagonal elements are 1. Right, so if you create a 3 by 3 matrix, then all the diagonal elements, it will be 1, 1 and 1. So let me demonstrate this. If I create a7 and do np.I and suppose I want to create a 3 by 3 matrix with diagonal elements as 1. I just simply do this and then I print a7. So this will print a 3 by 3 matrix with diagonal elements as 1. So this is how a NumPy array is created and it works, right? So moving on to the next slide, which we have is the 4 essential attributes of NumPy, right? So let me tell you what are attributes. They are basically the properties which are used to check the shape, the dimension, the size, the data type, and so on of a given array or so, right? So here we have an example of a 2D array which consists of 1, 2, 3 and 4, 5, 6 elements, right? It's a 2D array and we are calculating the shape, ndim size and data type. So let's do this practically, right? So if I create an array, suppose let that array be A, and if I create this, A is equal to np.array, and I pass the parameters like 1, 2, 3, and I pass 4, 5, 6, right? And then I do the shape one, right? So what is it's a dot shape, right? So this is going to give me 2, 3, which means it has 2 rows and 3 columns. And to explain this in a better way, let me show you how it prints the NumPy array, the 2D one. Right, so if I just simply do print A, it will show. As you can see, it has 2 columns and it has 2 rows and 3 columns. Right. So the next we have is ndim. The next essential attribute we have is ndim. Right. So let's do with the ndim part. If I print the dimensions of this like a dot ndim, so the dimensions of matrix is a 2D matrix, so the dimensions should be obviously 2. Like if I print this, it will give me the dimensions of the NumPy array to be 2 because it is a 2D matrix, right? The next part we have is the size. Here size refers to the number of elements in the array. Like if I have 6 elements, so if I just simply print a dot size, this is going to give a dot size. This will give me 6 because there are 6 elements in the NumPy array, right? So as you can see, this gave me 6, right? So moving on to the next type, we have the data type attribute. The data type attribute basically prints the elements stored in an array, right? Like here, the elements are stored as the integer. So if I do the print a.dtype, it will give me int 64 because the elements stored in the array, they are basically int 64, right? So if I do this, I'll get int 64. So this is the 4 essential attributes, but we have one additional feature too, like it's basically for type conversion. Like if I want to convert an array to float, like currently I have this, it's int 64, and if I want to convert, then I just simply need to do here a is equal to a dot as type, and I just simply do float, right? I change to float, and then again I'm going to do print a dot dtype, right? So as you can see that this changed the data type of int64 to float64. So this is how basically the attributes work in NumPy, right? So moving on to the next part, or the next slide, we have indexing, slicing and Boolean masking, right? So let's start with 1D array. So let me create a 1D array as quick as possible. So let me name this array as B, right? So B is equal to np.array, and I'm going to pass the parameters again like 1, 2, 3, 4, 5, 6, right? So now for indexing, we have multiple operations. Like if I want to print the first element, right? So as you know that there are indexes, like for the 1D array, the first element is at index 0. I guess you all know this, right? So if I print B, B's 0th element, like it's the index. So it will give me the first element. Like if I do this, I'll get 1. Yeah, so as you can see, I got 1 because 1 is the first element of B. Now, coming to the other functions, like we can print the last element too. For that, like if we want to print the last element, we can just simply do B and -1. Here -1 refers to the last element, right? So it's for the last element. As you can see, we got 6, which is the last element, right? So now, we have more operations too. Like if we want to print a range, right? So if we want to print the number of elements from the 2nd position to the 4th position, right? So for the 2nd position, which is 2, we have the index value as 2, and we want to print till 4th position, which is 4, right? So in NumPy, if you want to print that so for in NumPy, if you want to print that kind of thing, you just simply need to do like print, and you need to put the range. Like if I want to print the range, so from index 1 to 5th, since we are printing till the 4th element, right? So we need to add the second part. So since we are doing for the 4th element, we just simply need to add one more to the number of element till we are printing, right? So if I do this, we get 2, 3, 4, 5, which are at first index, second index, third index, and fourth index. So this is how it works. So we covered 3 of them, and we are now left with just one move, which is printing every second or third, right? So if I want to print every second element, I just simply I'm going to do B, and then I'm going to put colon, so I'm going to put colon, and then 2. This will print all the second elements, like the second element starting from 1. So 1 we have, and then the second element is 3, then 5, and if there would be 7, then it would have been printed 7 too, right? So this is how it works in 1D array. Now moving on to the 2D array, where we have row and column. The things work similarly, but it's kinda different, right? So just let me demonstrate this also. Like if we are working in a 2D array, so just let me create C is equal to np.array, and we pass the parameters again, like 1, 2, 3, and 4, 5, 6, right? So we have the 2D array, and now we are going to perform operations on this. Like if I'm gonna do print, C, and I pass the rows and columns, I wanna see the element at the index of row 0 and the index of column 1, right? So what will I get? I'll simply get, in this case I'll get 2, because let me show you. Sorry, np.array. Okay, so I missed braces, sorry. Yeah, so as you can see, I got 2. This, let me tell you how I got 2 here, right? So if I just simply print C here, we have 1, 2, 3, and 4, 5, 6. So as you can see that at the index 0 of column, we have 1 and 4, right? At index 1 of column, we have 2 and 5, and at index 2 of column, we have 3 and 6, right? And in this case, we passed 1 as index, so we got 1 for the column, and we passed 0, 0 here. The index for the row 0 is this 1, 2, and 3, and index for the row and index for the second row is 1, right? So this is how it works basically. We printed the index 0 of row and index 1 of column, so we got 2. So this is how it basically works. We have more operations too, like entire first row. If we want to print, then we're gonna simply do print C, and then pass the parameter like 1, this for entire entire second row, because here 1 is the index. So if we are gonna do print, it will print the 4, 5, 6, which is the second row, right? So this is how things work in the 2D array. Now after 2D array, let's move on to the Boolean masking section, which is honestly the best of all, because it just reduces the manual calculations, and so sorting so much easier. Like it just make things so much easier to do, right? So just let's go to Boolean masking, right? So for Boolean masking, let me do one thing, like Boolean masking, right? So now if I want to demonstrate an example of Boolean masking, it basically creates a filter, right? If the value is true or false, it works kinda like that. Like if I pass a parameter, like if I give an array of scores and I pass a parameter that mask or anything, it should be greater than 60 in scores, right? So, and then when I use that mask along with the initial scores, then I get the values that are more than that. I may sound a bit complex, but let me demonstrate this also, right? How this works basically. So let me create an array of scores, right? So if I create an array where 30, 42, 75, 62, 34 and 81, let me 16, right? So I created this array, right? Now I want to create a mask. So if I create a mask is equal to scores which are greater than and equal to, for example, I passed here 50, right? So I passed here 50. Now I need to create another variable to store this. Like if I create a variable called passing and I store scores along with the mask, and now finally when I print the passing variable, as you can see, I got 75, 62, 81 and 16. All the values which are more than 50 or equal to 50, I got them. So this is basically how Boolean indexing works. Like it just checks alternatively, is the value true or false, right? So this is how it works. So I guess we completed Boolean masking too. Now let's move on to the next slide, which is live coding demo, or we have so let's move on to the next slide, which we have the live coding demo, and I guess we already completed the live coding part, but let me show you one more example before ending this, like the time one which I showed you before. Like in the initials, I showed you that how the NumPy is faster than list. So let's demonstrate an example of that case also, right? So it's basically speed benchmarking, right? So if it's speed benchmarking. Okay, so let's create a program for speed benchmarking where we will use time library to calculate the time for both the operations of NumPy and list and check which one is faster, right? So just let's create import time. NumPy we already imported, that's why we are not importing this time. So we imported time. Now let's create a list and let's set a range of 1 million, right? So we set a range of 1 million and then let's create a NumPy array too, right? Let's create a NumPy array. After creating a NumPy array, let's now use the time library to calculate the time, right? And now let's store the result of the calculation, result of right. So now we are storing the result part for x in lst, and we are going to print a string, and we're going to print list time dot time t dot f sec, and now we're going to do the same for NumPy 2, right? So result equal to error. Yeah. So we did for NumPy 2, right? So now let's execute this and check the time differences between the list and NumPy, right? So as you can see, the NumPy is much faster than the list. So this is why, as I said earlier, that the list consists of multiple things to make it more flexible. Like list consists of strings, integers, floats, and another list inside them. So that's the thing, we use NumPy. For a small case scenario, it won't matter, right? But as you go and proceed to further, when you need to work on big data sets, then it can cause a major issue while performing these, right? So with that said, let's end video 1 and we'll continue this later in video 2. And that's a wrap on video 1 basically. Now you can create NumPy arrays in 6 different ways: inspect their shape and type, slice them in 1D and 2D, and filter them with Boolean masking, and so on, right? So let me give you a brief gist about video 2, where we're gonna go deeper into vectorized operations, broadcasting, aggregations, and when we finish this all thing, then we're gonna build a mini project in video 2 also. Right, so the notebook link is below in the pinned comment or the description. You can go check it out, and you can find all the other resources on hackskill.in once you enroll in the workshop. And for the content, it's obviously free and available on YouTube. You can definitely view it, but for the certification, if you want, you can visit hackskill.in and register in this workshop. So thank you guys.